Hey everybody, Johnny here. In this video, we're going to extend a few options from my previous video on making a tank track. But before we dive in, I just wanted to say, if you're finding my videos helpful, or if they're inspiring you to make anything awesome, consider subscribing. I've noticed only about 25% of my viewers are actually subscribers, so if you wouldn't mind clicking that subscribe button, that would be awesome. Let's jump into the tutorial. Now this is basically where we left off the previous video, where we have a tank track that is driven by geometry nodes. It's comprised of a mesh object with a geometry node set up on it, which is the actual track here. That's fed with a curve, which represents the path that the track is taking. In addition, it's also passed in a link that will become the treads of the track. And with the way we have this set up, whenever our animation is playing and we move this track, however far it moves in the direction of the track will spin. There's a few additional options that I wanted to add to this track, and I thought I'd go ahead and make a video about it so that you can see some additional things you could do to extend this to not only work with things like tractor tracks or tank tracks, but you could also do this to drive chains or other types of things like this. Let's look at the first option I wanted to add. This one is pretty simple. We want to be able to set the material on our treads. Now our treads are being brought in here with this track segment input, and they're being fed into this object info. Well, it's very simple to assign a new material to an object we're bringing into our node tree. And to do that, all I need to do is add a set material node. And this will go after the object that I've brought in, and then I will drag a socket to the material of that node. I'm going to go ahead and create a material that's going to be put on this, and we'll just do something simple. We will make it a dark gray color. Now to make this show up on our track, we'll go to our modifier, and for the material, I will choose my track material 1. So that's a pretty easy setup to do. Let's move on to our next option we want to add. Currently, the track will only spin if the entire track object is moving. And in that case, it will turn as much as the distance that it moves. But what happens if you want it to spin in place? Well, we're going to need to add some additional nodes here to add in more rotation after the simulation is done. So if the simulation has said don't move at all, we want to still be able to add some hand-keyed movement into our track. So currently, the movement that we do get is in this simulation zone. We want to add more or less rotation on our track after that's been evaluated. So I'm going to take all of these nodes that are after our simulation and drag them over just a little bit here. If we come down into our simulation, we can take a look at the nodes that are actually doing the track rotation. And that is, for each point of our curve, we're giving it the position of a point further down the curve, and we're doing that for each frame. So if we can just do this process again, but one time outside of the current simulation, we can then add a succinct amount, and we can keyframe that later. So I'm going to go ahead and I'm going to take all of these nodes that are currently doing that rotation, and I'm going to duplicate them, and I'm going to bring them over here. We're going to be taking the curve that we're outputting from our simulation, and we're going to run that into our new set position node here, and then come out of our new set position node to where our simulation was going. Now, of course, right now this is going to destroy anything we have here because we haven't hooked up the rest of it yet. We are sampling that same curve to get the position at a certain length. But let's see what that length is that we're getting. We're getting the length of the point that we're currently at. We add something to it, which right now is 0, and then we wrap that going from 0 to this other value, which is the length of our curve. But right now, we're not feeding that with anything, so this is wrapping this 0 to 0, so this is just messing up the whole thing. So we do need to grab that same curve length. And we're going to get that from the same source that we had over here, which is the original path, and we resampled it to a count of 100 to get a nice smooth rotation around the whole thing. So I'm just gonna do a cut in this with a shift, drag, right click, and I'm gonna bring that over here as well. Now, if I take this value that we're adding into our length, you can see that that then rotates the tracks around the curve by that amount. And that amount should be the curve length in actual Blender units. Now, of course, we will want to be able to keyframe this outside of our node in our modifier. So we'll go ahead and we'll add an input, group input, and we'll hook up a new socket to that value. And we'll name that extra rotation. So now over here from our modifier, we can in fact add extra rotation to whatever it currently is. And this will happen after the simulation. So you could be moving this, it will evaluate the movement, and then you could add in additional rotation in either direction for whatever you want there. Now, of course, if you were doing this and didn't need the movement like a tank tread, but you were using this for, say, a chain drive, where the chain path is going to stay stationary, so you don't have to worry about that simulation movement, you could go ahead and get rid of all of this simulation section and just drive the whole thing with this part here. And then you could drive that with, say, the rotation of a bone or a wheel or something like that, and have this track nicely to another object. One of the other things I was thinking about adding was what happens when you have a tank track that is really comprised of more than one type of segment. Let me explain. If we take a look at a tank track like this one, this is a single piece tank track, which means that each segment that gets bolted together to form the tread is exactly the same, and it just bolts into the next tread in order to create the shape that you want. So these prongs here are simply being bolted to the center of this pad above this next pad. You can see that here in this particular image where each track is just connected to the next one. Here's another example of the same sort of thing where you have a hinge on one side and a tube on the other side that corresponds to the gap in the hinge on this side, and they simply line up track after track after track. So the track that I already have set up basically follows this pattern, where I have the hinge on one side and this hole on the other side that can connect to it. But what happens if the tank track that you're trying to model doesn't follow this pattern? Let me show you an example. Take, for instance, these tracks. You'll notice with these treads that the end of one track does not directly connect to the next track. There isn't one hinge between each track. There's actually these little bars in between each track, so there's another hinge in between each track. So how is it that we could do this with our current model, where we could provide two different types of tracks and have them alternate in this way? Well, let's dig into that. For this example, I'm going to use a chain instead of a tread, but the concept is exactly the same. So these are the links of a common bicycle chain. We have this inner piece and this outer piece, and when we connect them together, we end up with a chain that looks like this. The first segment is going to be one of these outer chain pieces, and then the second link would be one of these inner chain pieces. So let's see how we could take our current tank treads that are one segment per link and change it into these alternating segments. So to start with, we're going to go over to where we brought in our tread, and we're going to duplicate that so we can bring in a second tread. I'm going to rename my existing sockets to track segment 1 and track material 1. And then I'm going to come down to this second one here, and I'll connect a new socket here, and a new socket here. I'm going to move my extra rotation up a bit. And then I'll rename these new sockets to track segment 2 and track material 2. So now I can bring in a second type of track segment. And now to connect these, I'm going to add a join geometry node, and we'll join those together. Now, right now it seems like we're back to where we were to start. So if we go ahead and we pick our two new link types here, which is chain link A and chain link B. So here for my track segment 1, I will choose chain link A. And then for track segment 2, I will choose chain link B. When I zoom in here, you'll see that we actually have these overlapping. So they're not alternating at this point. They're just going over one another at the same spot. So each one of these is just being joined together. And with the way we have this, it makes sense because all we've done is we've taken one mesh, we've joined it with another mesh, and so this is outputting a mesh. What we want these to be are separate instances. In each of these objects, we're going to bring these in as instances. So what that means is the meshes of these have been encapsulated with this idea of an instance. Now what you'll see is that we still have the same issue. They're being placed at the same location. Every instance we've brought in is being duplicated at each point on this chain. This is where if I come down to my instance on points node and I have my instances here, I can now choose pick instance. By default, what this is going to do is it's just going to cycle through our instances. So if we had, say, 5 different chain link types, it's going to pick number 1, 2, 3, 4, 5, and then just go back to the beginning over and over again. Now, we could use the instance index here to populate some kind of numeric pattern so that it did like 1, 1, 2, 2, 1, 1, 2, 2, something like that. You would just have to come up with a formula that worked on the point indices of the curve that we're working with and translated that to the number of one of your instances. But in this case, since we simply want to just go back and forth between two, just leaving this pick instance on does that for us. Something to consider though is that before, when we were choosing how many links to put in this chain or how many tread pieces into this track, it really didn't matter if that number was odd or even because the tracks were all the same. Now that they're alternating and the alternates are the only ones that can technically connect to each other, we need to make sure that the number of points in this are even. So here, where we did our curve to points, this is where we determined how many final points were going to be in our chain. We already had 24, so that is even. But if I were to make this an odd number, you would see here where we end up with 2 of the same link types right next to each other. And so that is kind of invalid there. So when I bring this up to the number where it seems to work the best, that seems pretty close. I just have to make sure that this is an even number for the chains to work out. So depending on how precise you're going to need this chain to be visually, like if this is going to be off in the distance just a little bit and you can get away with a little bit of wiggle room, just kind of visually lining up the number of links here will work just fine. However, if you are needing this to be extremely precise, you're going to want to go in and make sure that the length of your curve is divisible exactly by the length of each one of your links in that chain. So I'm not going to go into that in this particular video. Maybe we'll do that in a future video, but I wanted to keep moving with these topics. So this example gives us if we have links that alternate, but that are the same length. Well, that's not always going to be the case. If we go back and look at those wheel cover tracks that we just looked at, you'll see that the covers themselves are about 3 or 4 times longer than the links in between them. So how would we go about doing this with our treads rather than just simple alternating where they're the same length, because it's not going to work out the same. Here's how I would go into that. So here I've created 2 new track segments. And so you see we've got the larger kind of pad piece here, and we've got the connecting pieces here. And these just kind of slot in here a little bit. So these are marked as OTTA and OTTB. If we were just to replace our current links with these ones, let's check out and see how that would look. So this gets close, but you'll notice the problem here is that the smaller segment is lining up with the previous larger segment, but they don't reach to the subsequent larger segment. And that's because each segment is expected to be this longer length. So how can we get rid of that extra spot there? Well, what we can do is we can take our existing points and we can get rid of the ones that we don't need. Now, I very purposefully made the smaller links here have half the distance between their connection points as the larger ones. That'll give us a simple 2-to-1 ratio when we're creating our new curve in order to fit these properly. Now, that doesn't mean that you couldn't do a more complicated ratio between the two, but for this example, we'll expect that the smaller pieces are half as long as the larger pieces. So here's my basic thought process. If we were to populate our curve with enough points to take the smaller piece and wrap it all the way around, but then we were to get rid of every third point, then we would have point, point, space, point. And that point, space, point would be the length of our larger segment. Let's kind of look and see what that might look like. For the moment, I'm going to take my points that are driving where my treads are showing up, and I'm going to hook that up straight to the output geometry. And then I'm going to do a set point radius just to make those a more manageable size. Now, how would I get rid of every third point? Well, whenever we want to get rid of something, a good place to start is the delete geometry node. And what point in the geometry are we actually wanting to start deleting things? Well, we want to start getting rid of points after the point at which we've determined how many treads should be on the track. Now we're just getting rid of every third one because one of them is twice as long and will cover the space of 2 of them. It's here, after I've gone curve to points, is where I want to delete some of those points. So here I'll add a delete geometry node and drop it onto the path. Of course, with no selection, this deletes everything, and we don't want that. We want to delete every third point. So let's go ahead and grab an index node, and this will give us all of the indices of our points. Now, there's a couple of different ways we could go about getting every third point. The first is we could use the wrap node, and we could wrap so that our values just go 0, 1, 2, 0, 1, 2, 0, 1, 2, all the way down the line, and then delete where that index is either 0, 1, or 2. Another way we could do this is using the integer modulo function. That's my preferred method, just because it's the one that my head goes to immediately. So I'm going to take this index, and I'll type in modulo, or mod, and you'll see the first entry here is integer math modulo. So all modulo is doing is it takes this number that's coming in and it divides it by the bottom number. And so we want this to be 3. Because we're talking about every third item. So that what that means is we will divide our index by 3 and then return whatever the remainder is. So when the index is 0, we divide that by 3. It goes into it 0 times and there's no remainder. So 0 modulo 3 is 0. If the modulo is 1, 3 goes into 1 0 times with a remainder of 1. 2, it goes into it 0 times with a remainder of 2, and then 3, it goes into it once with a remainder of 0, and the pattern repeats. So this output number here is going to be repeating 0, 1, 2, 0, 1, 2. And so we can say when this remainder is equal to some number, that's when we want to delete. So when it's equal to 0, we'll delete that one. So now we end up with this pattern here. But of course, you are going to notice that one of these spaces has a little larger gap. Well, there's a really good reason for that. Well, before, when we added two alternating types of links that were the same length, we needed to make sure that our number of links was even. That way, there would be enough so that each one would fit in nicely. Well, now we've got to go one step further. It still needs to be an even number because we're alternating our link types. But now, between the two links, those take up 3 units along our curve. And so each one of those pairs is going to be 3 units. And we need to have, and the pairs need to alternate. So we need to have our total length also be divisible by 3 and have that number be divisible by 2. So an even number who is also divisible by 3. So if I bump this up to 36, we have an even number, so they will alternate correctly, and it's divisible by 3, so the spacing is correct. So you can already see in these points that I've got a long space, short space, long space, short space, and so forth. So let's switch back to our links to see how this works. Well, we can see currently that nothing is connected. If I join my points back in with my geometry so that I get both the links and the points, you'll see that the points just aren't close enough. So I'm going to have to add more points to get this to work. While we're over here, changing our curve to points number, I'm going to go ahead and I'm going to add in a new input group node and connect up the number of points so that I can control that from my modifier as well. So I'm going to bump this up. And like I said, I'm going to want an even number that's also divisible by 3. So 72 is even, and 72 divided by 3 is 24. So that looks pretty good. Now we'll go ahead and I'm going to go back to my first frame, insert a keyframe, jump forward some frames, add a new keyframe. So let's play that and see how it looks. So overall, I think these few extra tips will help bring this track geometry node to kind of a whole new level for you. You'll of course have to tweak it as you try tracks of different sizes and various things of that nature, but I think it can be very helpful in a variety of settings. If you've made it this far, thanks so much for watching this video. I hope it's helpful. And like I said at the beginning, if you're finding my channel helpful, please consider subscribing and turning on the bell notifications so that when my new videos come out, you get notified right away. The source files for this project, as it stood at the end of my previous video and at the end of this video, are always available on Patreon. My link is in the description. So I hope this video inspires you to make something awesome. And until next time, I'll catch you later.